Hello there, students. This is Pre-Algebra Lesson 9-1, Chapter 9, Section 1. And this is a topic that's not very hard, but it's got uh, some new words and some new ways of looking at things that you probably already are familiar with that make it seem harder than it really is. So it's not really difficult, but there's some new vocabulary words we've got to talk about here. Okay, so in 9-1, we're going to jump right into things. Please get everything down that I get down. We're talking about things called relations and functions. Okay, a function, I'm just going to read it here with you. A function is a relation in which each element of the domain is paired with exactly one element of the range. Okay, so before we go on, domain, that's basically the x values in an ordered pair. Okay, so domain is like x, all right? When one of the domain is paired with exactly one of the range. Okay, the range are the values of y. So x are the domain, the range are y. Okay, the domain contains all the values of the independent variable. So domain is the independent variable. X is the independent variable. All right, these values are chosen and do not depend upon the other variable. And the range contains all the variables of the dependent variable, all the values of the dependent variable. So the range is dependent upon the value of the domain. These values depend on the values in the domain. Okay, so what all this is trying to tell you, one thing that you have to be able to do is identify whether or not something is a function. Is, that's supposed to be is it a function? We have to begin with knowing when that is yes a function or no it is not a function. So they're trying to tell you right here in the notes. All right, this is a function. And the reason it's a function is because, I'll highlight here for you, that this is a function because each domain value is paired with exactly one range value. Okay, exactly, that's the key word there. You can't have more than one. In other words, this too, it's kind of like these are the values of x, these are the values of y. So when they input a 2, they got a 1. So that's like the order pair 2, 1 is what that really represents. This is the order pair 4, x is 4, y is 3. 4, 3. This is like order pair 5, 4, and this is the order pair 9, 7. So these are the points in this function that we could plot these points if we wanted to. But you notice I didn't have a situation where one of the domains repeated. Okay, now so this is, yes, this is a function. Yes, it is, and that's what they're telling you here. And they're telling you that here too. Now over here, this one is not a function because look right here. This 2, this x value for 2, it gave me the points 2, 1, and it gave me the points 2, 3. You cannot do that. You can't put 2 into a function and get two different outputs here. And so they're trying to tell you here this is not a function because 2 in the domain is paired with 2 range values, 1 and 3. So it's not a function. So immediately you can really stop right there. That is the big signal that this is not a function. Okay, so that's one way to look at that and to identify if something is or is not a function. Well, a function can be rewritten as a rule that is an equation, like this. That is a function. Y is equal to 2x plus 3. All right, a function rule describes the operations performed in the domain. Remember, the domain is x, and that's the input, okay, to get the range values, which is the output. So in other words, if you input a value for x, it outputs a value for y. Input, output, domain, range, x, y. All right. A function that is written as an equation can also be rewritten in function notation, such as this. So here's what they're telling you here. That let's say we had this equation, y equals 2x plus 3. This is the same thing, just written in function notation. So these two things are the same. Now let me point out what's going on here. Notice how this says y equals, and notice how this says f of x, f parenthesis x. So this is just a different notation. This is an algebra notation that you do need to be familiar with. Okay, it's an algebra notation. So if you see that F parenthesis Y, or they could change that letter F to another one like G, all right, what that means is basically Y. It means it's the output. Okay, so right here they're telling you the variable Y and F of X both represent the dependent variable, which is Y. Okay, so then what we do is we say, well, what if I said what if X is 4 in this equation up here? So if X is 4, you could probably put that in. 4 times 2 is 8 plus 3 is 11. But what we do is we write it like this. We might say F of 4 equals 2 times 4 plus 3. You see how I took this equation here? All right, instead of writing y equals, I use the function notation, f of 4, and then I just substitute that 4 that was here in for that x there, because it's saying like, what is x? What is the value of the function when x is 4? That's 8 plus 3, so f of 4 equals 11. And that's what they're trying to tell you here. In function notation, the f parenthesis x is read. This is how you say it, f of x. So if I asked you to read this, f parenthesis x, you wouldn't say parenthesis, you would say f of x equals 2x plus 3. Then I said, what about f of 4? Then I would be asking you what is the value when that x is 4. Okay, so that's basically all the information in this lesson here today. First, identifying whether or not something is a function, and then 2, being able to find the values of functions when you have a certain value for the independent variable. Okay, going to the back side here, let's get this first part done here. This 1 through 4 says determine whether each relation is a function. So this is a yes or no question. Is it a function or not? Well, probably the easiest way to do this is to work out number 1 down here. All right, kind of up here and down here. Watch what I do here. So the first part here, number 1, basically the domain are all the x values. Okay, all the x values. So all of the domain, you have 8, 4, 6, and 1. You have 8, 4, 6, 1. So that's the domain. Now the easiest way to do this, again, we are answering the question, is this a function? Okay, so the domain is we typically put it in order. So I'm going to go 1, 4, 6, 8. That is the domain. Now the range, okay, the range numbers, those are the y values. The range values are 2, 3, and 5. Now you don't have to write 5 twice because it ends up twice there. 2, 3, and 5. That is the range. Okay, so if I'm going to answer this question, well, when I had the domain, I'll just go in order here. When I had 1, the output was 5. So 1 output of 5. When I had a 4, 4 output of 3. When I had 6, 6 output of 5. And this 8 output a 2. So I've got all. So if I look at my domain, I see in no time did one of the domain repeat. So each domain has one specific outcome. This doesn't matter here. It's okay that 1 output of 5 and 6 output of 5. That doesn't matter. So the answer here, yes, this is a function for number 1. But if we do the same thing for number 2, watch what happens. All right, the domain, that's x. I'm going to do this a little faster now. All right, the x values, I have 1, 3, 7, 8. And the range, I have 2. I'm going to go in order here, but least to greatest 2, 4, 6, 9. That's a 9 there. Okay, so I'm going to go through my list here. Probably would be easy if I go up to my chart. So my input, 1 output of 4. So I'll do that. Whoops. Don't do that. Let's try that again. 1 output of 4. up here. 3, the top row is x, okay? So that's the domain. 3 output a 2, so that output 2. 8 output 9. 7 output 6. And then here, this 3 output a 4. All right, so right there, that's the answer right there that's I'm looking for. See how 3 output 2 different answers? Therefore, this one is not a function. I need a little more room here. Not a function. Okay. X equals 3 has 2 different outputs. Okay, so that's going to wrap up my first video here. So get all your notes down and come right back for part 2.